This is 2.2, graphing an intercept form. In the last section, we graphed in vertex form, and the reason it was called vertex form is it was really easy to find the vertex by just looking at the function that was given to us. Intercept form is another type of quadratic form, but it's not easy to find the vertex just by looking at it. What it is easy to find are the x-intercepts. So in this form, we have y equals parenthesis x minus something, and then x minus something else. So I'm going to go ahead and I'm going to use green and blue for these. So we'll say there's a green and there's a blue. Green and blue are interchangeable though. So these parentheses could be reversed and still give us the same function. So in any of these, whatever number is in the parentheses, you're going to take the opposite of it, and that's going to give you one of your x-intercepts. So if I look at this first guy right here, this is a -1. That means that my x-intercept is going to be +1, 0. I'm going to do the same thing with the other parenthesis. I see a +3, and that means I'm going to have -3, 0. So in this format, the first thing we find are the intercepts because they're right there in the equation. And then what I'm going to do is plot these x-intercepts. So I'm going to plot x equals 1, and I'm going to plot x equals -3. Then we find what's called the axis of symmetry. So axis is a fancy word of saying, a way of saying line, and symmetry means it divides something in half so that if I fold one end of it over to the other end, I get the same picture. We saw this symmetry in the vertex form because we had a point on the left and a point on the right that were the same distance from the vertex. So we're looking for this line. This line is going to be halfway between our x-intercepts. So let me write that here. So this is halfway between our x-intercepts. Okay. So to find halfway between our x-intercepts, we could count. So we could put our fingers on each of the x-intercepts and count in to figure out where the middle was. Or we could find the average or the mean, maybe the word that you know from statistics. So the x-intercept or the axis of symmetry, what I'm going to do is I'm going to say x equals, and I'm going to take my two x-intercepts, 1 and -3, add them together, and divide by 2. So what I'm doing is I'm taking green plus blue divided by 2, which is kind of cute because it rhymes. So 1 plus -3 is -2. And that gets divided by -2. And -2 divided by 2 is -1. Since this is a line, I'm going to get x equals -1. So I'm going to go to -1. And this isn't actually on the graph. It's an imaginary line. So I'm going to sketch just a dotted line to represent an imaginary line. Then I'm going to finally find the vertex. So the vertex is going to sit on the axis of symmetry. It's going to be on that line. So I know for sure that the x-coordinate of the vertex is -1. So this and this are always going to match. Then what I'm going to do is I'm going to go ahead and I'm going to do a little scratch work on the side. And I'm going to plug my x value into the original function. So up here, I'm going to say -1 minus 1 times -1 plus 3. And let me highlight those yellow so that we know that that's where those came from. So there are those, and this is green, and this is blue. So then let's see, -1 minus 1 is -2. -1 plus 3 is +2. So that gets me -4. -4 is the y value of my vertex. So that goes in purple. So I'm going to go ahead and plot that point. So I'll plot the point -1, -4. I already know where -1 is because I've got the dashed line. So along that dashed line, I just have to go down 1, 2, 3, and 4 and put a dot. And you can see now I've got those 3 dots. They're not exactly the same 3 dots that we had last unit, but they do give us our nice parabola shape. And then the minimum is at y equals -4, so that purple value. Okay. Let's try the next one. So for the next one, I'm looking for those x-intercepts. So I see +2 and I see -2, which means -2, 0 is one x-intercept and 2, 0 is the other x-intercept. So I'm going to plot them. So I'm going to say -2 and +2. So for this one, the axis of symmetry might be a little easier to see because we've got a -2 and a +2. Those are already the same distance from the y-axis, but let's calculate it anyway. So I'm going to go x equals for my axis of symmetry, and I'm going to do -2 plus 2 divided by 2. -2 plus 2 is 0 divided by 2 gets me 0. So x equals 0 is my axis of symmetry, and I think we use yellow for that. And I'm going to go ahead and take my pen and write down the y-axis, which is x equals 0. I'm going to draw a dashed line. Okay. So then we're going to go for the vertex. The vertex is on the axis of symmetry, so I know the vertex is going to be 0, something. I know that this value is going to match my axis of symmetry. So then I'm going to go ahead and do a little calculation. I could do it up at the top if I wanted to, but I have some space this time, so let me do it over here. And I'm going to say 0 plus 2 and 0 minus 2. So the zeros are my yellow values. The 2 is my green, and the -2 is my blue. And I keep calculating. 0 plus 2 is 2. 0 minus 2 is -2. And I end up with getting -4. So -4 is my y value. We colored that purple before. And that is going to be my minimum. So I'm going to say y equals -4. I'm going to plot my vertex. So 0, -4. I'm just going to go down 1, 2, 3, 4 on that dashed line and connect my dots. Okay, remember, nice smooth curve, no straight lines. Okay. Next example. So this one is a smidge different because there's a 2 in front. That 2 is actually going to do what the 2 did in vertex form. It's going to give us a stretch. So we're going to see a graph that is more narrow than probably the ones that we saw above. So we're going to start with the x-intercepts. Even though there's a 2 in front, the x-intercepts are still going to be the numbers inside the parentheses. So my first x-intercept is going to be 5, 0. That was the green number. And my second x-intercept is going to be -1, 0. And that's the blue. So I'm going to go ahead and plot those. So I'm going to go to the right 5. 1, 2, 3, 4, 5. And then 1 to the left. There we go. Then I need my axis of symmetry. So I'm going to go ahead and I'm going to take my green value and my blue value and divide them by 2. So I'll go ahead and highlight those. That's green and that's blue. And I'm always going to divide by 2 because I have 2 points. So that's going to give me 4 over 2, which is 2. So my axis of symmetry is x equals 2. We were using yellow for that. And I'm going to draw a dashed line right down x equals 2. My vertex is going to be somewhere on that line, so I know my vertex is going to be 2 comma something. So that 2 is because of that yellow value. To find my vertex, I'm going to go ahead and plug into the original function. So this time I've got a 2 in front. I'm going to say 2 times 2 minus 5 and 2 plus 1. So these 2's that I'm highlighting in yellow are from my axis of symmetry. I've got my x-intercept and my x-intercept. The 2 in front came with the formula, so that's why we're including it. So we've got 2 times -3 times 3. 2 times -3 is -6. -6 times 3 is -18. So we're going to have -18. And we were using purple for that. And on this grid, it only goes to 10, to -10. So we're going to estimate. So I'm going to go ahead down here, and I'm going to say, oh, -18 is about there. Okay, you get as close as you can. And then I'm going to go ahead and sketch in my parabola. There we go. And then the minimum is y equals -18. And that -18 matches my vertex y value. For the next example, we have a negative sign in front. That negative sign is going to do what negative signs in front did with vertex form. We're going to have an upside down parabola. But the vertex or the x-intercepts are still the same. So I've got a green value and a blue value. And so -2, 0 is one x-intercept, and -6, 0 is the other x-intercept. And I can label these with green and blue so that we see that they match the function. I'm going to go ahead and plot those points. So I'll plot -2, 0, and then 3, 4, 5, 6, -6, 0. We're going to find our axis of symmetry. So I'm going to say x equals, I'm going to take green value plus blue value and divide by 2. It's always going to be adding them together, and it's always going to be dividing by 2. So that gets me -8/2, which is -4. So x equals -4, which we've been labeling yellow. So at -4, I'm going to go ahead and I'm going to sketch in my axis of symmetry. My vertex is going to be on that line, so the x value of my vertex has to match, and that's going to be at -4. Then I'm going to find my y value, so I'm going to say negative, I'm plugging into the original equation. I'm saying -4 plus 2 and -4 plus 6. And just to label these, the -4 is the yellow value that we've got. The green value is the 2, and the blue value is the 6. So then I've got a negative sign inside the first parentheses. That's going to give me -2. Then I've got -4 plus 6, which is +2. -2 times 2 is -4, and a -4 is +4. So that's going to be a +4, and we were labeling that with purple. So I'm going to plot that point. I'm going to go to my axis of symmetry, and I'm going to go up 4. So 1, 2, 3. Let me count again. 1, 2, 3, up 4. There we go. And just as we predicted, this parabola is going to open upside down. It's not a perfect parabola, but that's okay. They don't have to be. They just have to be curvy. And the maximum is going to be y equals 4, and that 4 matches the purple 4. Next example and last example. So this one has a little bit of everything. We've got a negative sign, so we know this parabola should be upside down. We've got the 2, so we should have a little bit of a stretch to it. And then I see 2 sets of parentheses instead of parentheses squared. So parentheses squared is vertex form. Parenthesis, parenthesis is going to be intercept form. So I'm going to go ahead and identify my x-intercepts. So I've got green and blue. They're both negative. So when I plot these, or when I label these, I'm going to have +7, 0, and +3, 0. The 7 is the number that was green, and the 3 is the number that was blue. I'll go ahead and plot these. So I'll plot 1, 2, 3, and then 4, 5, 6, 7. So there are my 2 x-intercepts. Axis of symmetry, I'm going to say x equals, I'm going to take my green and my blue numbers, so 7 plus 3 divided by 2. So that's 7, 8, 9, 10, 10 over 2, which is 5. So x equals 5 is my axis of symmetry. We were labeling that yellow. And I'm going to go ahead and go to 5, which is halfway between those 2 dots, and put in my axis of symmetry. Then I go to the vertex. Vertex has to have an x value of 5. That's where the axis of symmetry was. So that yellow number goes there. For the y value, I'm plugging into the function because the function says y equals. So I'm saying -2 times 5 minus 7 times 5 minus 3. So in this, the 5's came from the axis of symmetry. The 7 and the 3 came from my x-intercepts. So searching for that y value, I've got -2 times 5 minus 7 is -2. 5 minus 3 is 2. -2 times -2 is +4. And 4 times 2 is 8. So I get the point 5, 8. And 8, we were using purple. So I'm going to my axis of symmetry. I'm going to go up 8. So 1, 2, 3, 4, 5, 7, 8. Hopefully I counted right. And there's our 3 points that are going to help shape our parabola. So just do your best to make a nice parabola shape. Shouldn't be too much of a sharp point at the top. Nice and curved. And then the maximum, because this does open down, is y equals 8. And that 8 matches the purple 8.